Here's a big fat 19-mark question. It was badly answered in the exam by lots of candidates. This question is probably the difference between having a good S2 paper and a bad S2 paper on this particular one. You need to be able to handle this. It's a continuous random variable, and they're giving us capital F's and little f's. First thing is always to check whether you're dealing with a rectangular distribution. But there are two different rules going on here. You're unlikely to be fooled this is rectangular, so check it isn't and move on. We've got to sketch the graph of this. Don't forget the end sections. Do show the value of 0, and certainly show past 4, show that capital F of x has become 1. This should be an easy graph to sketch. This one here, a bit trickier. Okay, and they would like to see some details of the curve. So we'd like to see at least some indication on the axes. You need to show 0 and 1 and 4 as a minimum here. And it will be helpful anyway to show this end point or this crossover point here at 1. What has capital F of x got up to at 1? So show this point. This section of graph is easy. The section of graph between 1 and 4 is clearly curved. You need to show which way it curves. You can do quite a bit of core 1 work on that cubic to decide, or you could just tabulate maybe a few values between 1 and 4. Your calculator will probably do that for you, but don't just guess which way it curves. You may guess wrong. Explain why the value of the lower quartile of x is a half. So you need to know what the lower quartile means. We're dealing with a capital F of x here. The graph ends up at 1 and staying at 1. Don't get it mixed up with the other graph of the probability density function. Lower quartiles are to do directly with capital F of x. Remember, capital F of x is the probability of being less than or equal to that x value. So for the lower quartile, we want the probability of being less than or equal to that value to equal a particular thing. It's a quartile. You need to decide whether you're in that section or that section of the graph. If you know the probability of being less than or equal to 1, then depending on whether that is more than a quarter or less than a quarter, that is the giveaway about whether it's this equation that applies or this equation that applies. But once you know which of these applies, you just equate the relevant one to the right probability for the lower quartile, and you go ahead and solve. And that's an easy equation leading to a half. It's a show that, or it's an explain question. You need to be convincing in getting there. So your method needs to be watertight. And then we've got another show that question, this time for the upper quartile. This time we haven't got a particular value. They're showing there's an answer in a range. And that's because it isn't a particularly easy equation you're going to have to solve. It's not going to be this one. You're going to be solving that equals something, the right thing for the upper quartile probability. Solving a cubic equation can be tricky, but you're not actually trying to get the answers to correct to 3 significant figures. We're getting an answer in a range. If you remember your core 3 stuff, you've got a method for showing an equation's got a root in a range. Or you can just do a bit more of a direct approach here by just showing that 1.6 is a bit too low. So the probability of 1.6 or less isn't quite big enough, and the probability of 1.7 is a bit too big, and state what the value needs to be, and you can get away with just substituting 1.6 and 1.7 into the correct equation and comparing with what you want the answer to be. If you're convincing in the way you express that, you should be able to get those 3 marks. On part B, we've now got a probability density function, and it's again got 2 rules. What you need to pick up is the probability density function of x. This is not a wholly new question. This refers right back to the top of the question, where x was something to do with fans gaining entrance to an event. The point is about that top section is they're setting up an x that applies to the whole question. So this x in this part is the same distribution as this. So we're going from a capital F of x to a little f of x. So that's your way in to getting the values of alpha and beta, because all you have to do to get little f of x, if you know capital F of x, there is a rule. You do a particular thing to capital F of x to turn it into little f of x, and then you can see what alpha and beta are just by plain algebra. Once you've set up alpha and beta, or have them set up for you, this is a re-entry point here, getting the expectation of x from the probability density function on page 11 of your formula book. There are all the integration formulas you need for calculating things like expectations and variances of continuous random variables. Set up the integrals, there'll be two of them, you need for the expectation of x. Use the given values of alpha and beta, use your limits here, and you should be able to get that 5 marks even if you had a bit of a disaster on the earlier parts of the question. Hope that all helps.